Let's just take a quick step back now and note that we've seen what are three qualitatively different types of what might sort of casually be called, quote unquote, long distance dependencies in English syntax so far. And I bring up long distance dependencies because you'll see very often very casual reference to the fact that there are long distance dependencies in natural language. And there are several formally different classes of those, and I want to distinguish them. And we've analyzed each one differently here. The first is what we might just say it's a pair of categories that is separable by an unbounded number of tokens. So in this case, for example, words, as exemplified by the following pattern. So I ate is a perfectly reasonable sentence in English. I ate a sandwich is also a perfectly reasonable sentence. Now, and sandwich stand in this following kind of dependency relation. The word is a determiner, and it introduces a requirement that eventually you will get to a noun before you're done with some part of the sentence. In the present context, minimally, you'd have to have a noun before you can finish the sentence at all, or go on to certain other kinds of phrases. And the reason is because the determiner actually introduces a phrase type, which is the noun phrase or determiner phrase. So while I can separate out and sandwich, for example, I can say I ate a big sandwich, or I ate a very big, freshly prepared, extremely tasty sandwich. I can make that modification structure even more complex, but none of it gets me off the hook from having to finish that part of the sentence with a noun. So I can't continue on and say I ate a very big, freshly prepared, extremely tasty, and wonderfully cheap, and then period. That would not be okay. I can add modifiers, but I'm in a state where I need to get a noun before I'm done. And this type of dependency can be modeled with finite state methods. We've already seen this. So for example, here's a little automaton that would accept the kinds of sentence sets that we've illustrated here. My start state is I have the subject, for example, the word I have a verb, that's the main verb of the sentence, and now I could stop, right? Because it could be an intransitive usage like I ate. But if I have a determiner, so that being able to stop is illustrated by the fact that this is an accepting state. It is a final state. And so I could stop there. But if I don't, if I have a determiner, now I can't stop until I eventually get this noun. I can have adjectives stacked as much as I want. Each adjective can have as many adverbs before it as I want. But I have to have that noun eventually in order to get to another accepting state. So that's long distance dependency number one. Long distance dependency number two is a pair of categories of words that are separable by an unboundedly deep nesting of phrases. So the nested if-then examples is a good case study for that. So for example, if students work hard, then they generally do well in class. And I could nest that with additional if-then. So for example, I could nest inside the first part of the if-then. If it is the case that if students work hard, then they generally do well in class, then the teacher is rewarded, and so forth. And I've used color coding to match, to identify matched if-thens. This type of dependency could not be modeled with finite state methods, but it can be modeled with context-free grammars very straightforwardly. So for example, the set of rules that I've illustrated here allow me to do this arbitrary nesting of the form that we see here. So that's the second type. The third type is a pair that is separable by an unboundedly long chain of tree nodes. So for example, and in this case, the dependency that we've used to exemplify this in extraction is not a dependency between the presence and presence of elements, but it's the presence of element with the absence of an element somewhere else. So a slightly different kind of dependency. This requires a little bit more machinery, but it is still within the scope of context-free grammars used appropriately. So this is things like, who did Kim invite to the party? Who did you say Kim invited to the party? Who did you say Pat suspected Kim invited to the party? Who did you say Terry texted that Pat suspected Kim invited to the party? And so forth. And this requires this feature passing through the categories. So I create this missing an NP annotation, and I allow it to propagate through a chain of categories. And I do that by having the right rule inventory, including at the very bottom that a category that's missing itself rewrites as the empty string. So those are the three different types of long distance dependency. We're still within the context of being able to model everything with context-free grammars, but we have to be careful about the machinery that we deploy. And now we'll go on next to some remarks about formal language theory and context-free grammars and beyond.